This table summarizes quite well all the transformations that we have learned. Now, what happens if there are multiple transformations that involve in one single function? In that case, we do have to follow a certain order. So here's the order of transformations for graphing. First, we will perform the horizontal shift. Then we will perform the horizontal and vertical stretch or shrink. The third one is reflection across the x and y axes. And then last, then we'll do the vertical shift. So let's do an example that involves multiple transformations. Here we have the function q of x is equal to negative 1/3 times absolute value of x plus 2, and then minus 1. First, we need to identify the parent function. I see here the parent function is the absolute value function, which I remember the graph of this function is a V shape, and some critical points are 0, 0, 1, 1, 2, 2, 3, 3, and on the other side, we have similar points, but just on the negative side, here negative 3, 3. And if you connect, you get a V shape. Now, let's perform the transformations using the order. So one, let's look at the horizontal shift. Horizontal shift is when you look to see if there's any numbers that is directly subtracted from x or is added to x. I can see that 2 is being added to x directly. So there is a horizontal shift, and that is shifting left by 2 units. X plus 2 means shifting left 2 units. When you transform, you will keep the y variable the same, and then as for the x variable, you are going to subtract 2 from it. The next one, is there a horizontal and vertical stretch or shrink? Yes, I see that there is a number that is being multiplied on the outside of the parent function. So that indicates there's a vertical shrink because the number is 1/3, which is between 0 to 1. So there is a vertical shrink. And when you transform the points, you're supposed to keep the variable x the same. And then as for the y coordinate, you are going to times it by 1/3. Next, we have reflection across the x and y axes. I see that there's a negative sign in front on the outside of the absolute value function. So that indicates that there is a reflection across the x-axis. So reflect across the x-axis. And in that case, we will keep the variable x the same, so keep the x coordinate the same, and then we will add negative to the y coordinate. And lastly, is there a vertical shift? Yes, I see there's a -1 at the end and on the outside of the absolute value function. So that indicates a vertical shift, and that is shifting down. So vertical shifting down by 1 unit. And when we transform, we will need to keep the variable x the same, and then we'll subtract 1 from the y coordinate. So let's apply all the transformation that I wrote in pink, and we are going to transform 3 points. So some critical points from the original function, absolute value of x. I'm going to use 0, 0, and maybe 3, 3, and maybe -3, 3. So the first transformation we'll do is we'll keep y the same and subtract 2 from x. So that will become 0 minus 2 is negative 2, and keep y the same. There's the first transformation. Second transformation, now we need to keep x the same, so negative 2 will be kept the same, and then you will times the y coordinate by 1/3. So 0 times 1/3, that's still going to be 0. So there's a second transformation. And the third transformation, we are supposed to keep x the same, so x stays negative 2, and then y, apply the negative to it. Negative 0 is still going to be 0. So there's a third transformation. And then the last transformation, that's when we'll keep the variable x the same, and then we subtract 1 from the y coordinate. So that's going to be negative 2, keep it the same. 0 minus 1 will give you negative 1. So there we have a new point, negative 2, negative 1. Let's transform the next point. Okay, again, first, we will subtract 2 from x and keep y the same. So 3 minus 2 is 1, keep y the same. And next step, times y by 1/3, keep x the same. So x will now stay 1. 1/3 times 3, that will give us 1. So that's the second transformation. Third transformation, we are supposed to apply the negative to the y coordinate. So keep x the same, y will be negative 1. And last but not least, you'll subtract 1 from y, keep x the same. So keep x the same. Negative 1 minus 1 will give us negative 2. And there's our second point. Let's do the last one here. So first, subtract 2 from x, keep y the same. Negative 3 minus 2 is negative 5. Keep y is 3. Second transformation, times y coordinate by 1/3, keep x the same. Keep x the same, 3 times 1/3 is 1. Next, apply negative to the y coordinate. Keep x the same. So here's x. Apply negative to the y coordinate. And last, keep x the same and subtract 1 from y. Keep x as negative 5. Negative 1 minus 1 gives us negative 2. So there are the 3 points. Let's plot them on this graph. So we have negative 2, negative 1. That's here. 1, negative 2. That's going to be right here. And then negative 5, negative 2. That will be right here. And now we connect to get the graph. It will be an upside down V shape because there was a reflection across the x-axis.